Today we're going to start with a preview of calculus. We won't get very far. We will finish this up next class period. We're going to start by just talking about what calculus is. So a real basic definition for starting with is that calculus is the mathematics of change. So the first thing I'm going to do is show you a lot of slides that are not in your notes. They're in the textbook. You can see it, the ebook online. And we're just going to kind of try and differentiate the difference between things that are pre-calculus concepts and the things that are calculus concepts, okay? But the basic sort of overarching feel that we're going to talk about today is that calculus is the mathematics of change. So your paper actually says consider certain pages in your textbook. And there are two different kinds of concepts. And as we see this, the left-hand column are pre-calculus concepts. They're things that you've encountered. I'm not going to ask you to do all of them, so don't get freaked out like, oh my goodness, I was supposed to remember that? No, that's fine. But they're things you've encountered before. And on the right-hand side, it's the variation that we're able to do once we have calculus under our belts. And I don't mean necessarily Calc 1, but calculus in general throughout different portions of calculus. So to start with, without calculus, we are able to find the value of a function at a point. Right? I can find the y value right here. I can do that with calculus, with pre-calculus. Typically means I'm looking at a graph, or I'm plugging in a number for x and it's spitting out y. Right? We can do that with pre-calculus. But with calculus, we can actually find the limit of a function as it approaches a value. So if there's a hole in the graph, like you can see on this one, we can still find that value. If you were to try to find that value in some cases with pre-calculus, your calculator says error or invalid domain, things like that. But with calculus, we'll be able to find limits. With pre-calculus, we can find a slope of a line. You remember doing that, right? One of those big topics all the way along the way, finding slopes of lines. But we can actually find the slope of a curve with calculus. Okay? It's not straight. Can't do that with pre-calc. With pre-calculus, we can find a secant line to a curve. Secant line, if you'll remember, is a line that cuts through 2 points on a curve. So there's 2 points and it's cutting straight through. You can do that with pre-calculus. With calculus, you can actually find what's called a tangent line to a curve. So tangent lines, and probably secant and tangent lines are something you might even encounter first of all in geometry anyway. Tangent lines simply touch and bounce off of a curve. Right? So they're not cutting through 2 points in the curve, generally. They're just touching at this one point right here. That's a calculus concept. All of these we will happen to, these are all Calc 1 concept. These three are. A few others. So with pre-calculus, we can find the average rate of change between, hang on. There we go. With pre-calculus, we can find the average rate of change between two different times. Right? So you can figure out how far you drove, you can figure out how long it took you, and you can figure out your average speed. That's a pre-calculus concept. With calculus, we can find the instantaneous rate of change. Instantaneous means what your speedometer would actually say at any given point in time. It's the right now. Okay, that's instantaneous. So without actually being in a car physically, we can do that with mathematics as well, with calculus. With pre-calculus, we can find the curvature of a circle. Okay? But we can make it a broader topic, and we can find the curvature of a curve with calculus. With pre-calculus, we can find the height of a curve. That's kind of like this first one over here that said the value of f of x at c, right? We can find the height of something. With calculus, we can find the maximum height. When does it sort of peak out? So you'll remember in probably some algebra courses in high school where you had to find things like, find the maximum area inside of this enclosure so the dog has the most space to run around. Yes? And you did it with some algebra techniques because it was a very specific example of this, but we can do that with much broader examples with calculus techniques. With calculus, precalculus, keep bouncing back and forth. With precalculus, you can find the tangent plane to a sphere. Okay, so again, a very specific shape, a sphere. But then with calculus, we can broaden that to shape of any surface that we can find a tangent plane to. With precalculus, we can find the direction of motion along a line, one-dimensional, right? One-dimensional along a line. But with calculus, we can find it along a curve. Curve is a two-dimensional object, so we can extend our dimensions. With precalculus, we can find the area of a rectangle. Y'all know how to do that, right? You've been doing that for a really long time. Area of a rectangle is an algebra topic, basically, right? So these topics, this is the last one, actually, that we will do in Calculus 1. With calculus, we're able to find the area under a curve. And so the uniqueness is that that shape on the top is not straight, right? It's curved. Once again, we see that curved feature going on. Okay, so that's where Calc 1 will end. The rest of the topics are further on. Work. So without calculus, we can find the work done by a constant force. Okay, the force is consistently pushing at a constant speed with the same pressure all the way along, right? But with integral calculus, this is Calc 2 one actually, we're able to find the work done with a variable force. So it speeds up, it slows down, it applies more pressure, it applies less pressure. That's a variable force. With calculus, you can find the center of a rectangle. Without calculus, you can. But with calculus, you can actually find the center of any shape. Any region, you can find the balancing point. So you might want to imagine, right, like it's the tipping point that if you were to be able to find it perfectly, it would balance, like the basketball on your finger, right? That's what you're looking for when you're talking about the center of something. Without calculus, you can find the length of a line segment, right? You can measure it. It's straight enough, easy to do, ruler stuff, whatever. But you can actually use that same, with calculus, you can use the shape that's a curve to do that. So I can take a curve and I can find the length of the curve when I use calculus. And then we get to some 3D shapes. So again, pre-calculus, typically geometry stuff, you can find the surface area of a cylinder, right? The space around it. Well, with calculus, you can do that for any solid. It doesn't have to be a cylinder, any shape. You can find the surface area of a solid of revolution is what they're called. With pre-calculus, you can find the mass. So mass and weight aren't exactly the same, but they're similar, right? The mass of a solid of constant density, right? It's consistently the same, denseness throughout. But with calculus, we're actually able to do that with a variable density. So portions of the object actually are heavier than other portions. With pre-calculus, you can find the volume of a rectangular solid. Y'all know how to find volumes of something like that. Okay, that's geometry that we've encountered. But you can do that for any region, right? The volume of a region under a surface, any shape, you can do that with calculus. So all of those are actually Calc 2 that we kind of just passed through. And then this last one is actually Calc 3. In Calc 3, you can find, if without calculus, you can find the sum of a finite number of terms. Right, so if somebody told you to add together the numbers from 1 to 100, if you didn't know any tricks, it would be tedious, but you could do it, right? It's an addition process. But if they wanted you to do it from 1 to something and it lasted forever, we would run out of time, right? Like there would be no way to do that. Well, there are ways to find sums of infinite values with calculus. It's in Calc 3. So we're going to take a look next time, and I'll just briefly describe what we're going to do, and then we'll do it next time, at two specific examples that show the difference of using something with calculus and something with pre-calculus topics. So this is called the tangent line problem. So as I already defined before, a secant line is a line between any 2 points on a shape, and then a tangent line is a line touching only 1 point on a shape. So if we're using the shape that's a circle, secant line would look like that, right? If we're using the shape over here, and I'll use a couple of points, we'll use this point and this point, then the secant line would look like that, something like that. That's the secant line. It connects 2 points on the curve. A tangent line connects to only 1 point on the curve. So it looks something like this, would be a tangent line. And then for one of these shapes over here, a tangent line, we'll pick the point just right here, would be like right here. Okay? So we're going to consider next time what happens with a circle and how we use pre-calculus ideas, and what happens with a random, arbitrary curve, and how we can use calculus ideas to do that. Okay? We're not specifically going to do the calculus to do that, though. So we will pick up here next time.